This is Unit 12, Lesson 14, Part 1. These we are going to be learning about some new type of equation called trigonometric equations. So equations have equal signs. Equations means you are solving. So when we're solving here, we're solving for theta. Most equations you end up solving for x, but as you know from the last several sections, we've been using theta as our main variable rather than x. So with these equations, solving for theta means that we are finding an angle that makes these equations true. All right, so a lot of work with the unit circles. You definitely want to make sure you have that handy. We're going to be kind of working backwards on our unit circle. So with trig functions, remember trig functions are periodic, meaning you have the same values that repeat themselves over and over and over. So what that means is that you can have many solutions. You could have 1, 2, 3 solutions. You might potentially have no solution depending on the interval that's given to you. So every single equation is always going to have the given equation and then a provided interval. And so that interval will help you select which answers work and which answers do not, which means you have the possibility of having extraneous solutions. That just means the solutions worked, but that they were outside of this given interval. All right, so your goal with these ones, with these basic examples, is that you need to isolate the trig functions. Okay, so get sine theta by itself, get cosine theta by itself, get tangent of theta by itself. So on this first page, we're gonna work with basic examples. What that means is that nothing is squared. We have just sine, just cosine, just tangent that we're able to get by itself. So these will get us warmed up a little bit, understanding how to use the unit circle, and then on the next page, we will get into the more complicated examples. All right, so we will be starting with number 1. Remember, what you want to do is isolate the trig function. So here, think of this as just like a y. Like, don't worry about the sine of theta part. Treat it the same way you'd treat a y. 6y minus 3 equals 0. And you want to get that y by itself. So here you'd start by adding 3 to both sides. And then you divide both sides by 6. So divide by 6, we get sine theta by itself. 3 over 6 reduces down to 1/2. So here's how we solve the equation. We break out the unit circle. You're going to use the unit circle for every single problem. And what we are searching for are any angles that have a sine of 1/2. So on our unit circle, remember 1/2 is the y coordinate. So what you do is you look at the y and you just take the unit circle for a spin. I like to start here at the beginning, and you just go around the circle looking for the y values and looking for anything that matches. So we are looking for sine values that are equal to 1/2, and we actually find one right away. So this is either pi over 6 or 30. Make sure you're reading your directions carefully. These directions say for 1 through 4, give the solution in degrees. So make sure you're doing that carefully. So theta equals, the first one we found was 30 degrees, and we are going to do a full lap. Make sure we find everything we can. So we keep going, find 1/2. There's another one. Give our answer in degrees, 150 degrees. And then the better you understand this unit circle, the quicker this will go, because you may notice as soon as we cross into the lower half of the unit circle, all these y values are negative. So negative 1/2 doesn't work. This negative 1/2 doesn't work. It's only the exact value that you're looking for. So these are our 2 answers. Then finally, we watch out for extraneous solutions. That means looking at this interval and making sure our answers fit. 30 fits, 150 fits. So we box it up. We have 2 different solutions for that equation. All right, so that's the way that unit circle works. That's the way these problems work. Next one we're going to look at is number 4. So number 4 has cosine. This one, we have cosine in 2 different spots, but again, think of this as just like an x. Think of this like an x. You're just trying to get that x by itself. So you're going to start by subtracting this over to the left-hand side. So this would be like 5x minus 3x. That would be 2x. So this is just 2 times cosine plus the square root of 2 is equal to 0. And we just want to get that cosine part by itself. So next move would be to subtract the root 2 from both sides. So we get negative root 2 on the right. And our last move to get the cosine by itself would be to divide both sides by 2. So we isolate that trig expression, and our equation now looks like this. So now we take out our handy little unit circle. We're going to do a spin all the way around. We want the cosine value to equal negative root 2 over 2. So like I said, the better you know your unit circle, you can start to isolate your search. If we're looking at the x coordinates, X coordinates are positive when you're on the right-hand side and negative when you're on the left-hand side. Since we're looking for a negative root 2 over 2, you know that we really just need to focus our search on the lefts. Okay, so here's one right here. For number 4, we're still supposed to be in degrees, so this would be 135. Here's the other one right here. This is 225. So 135 has the X value we need, so does 225. So in degrees, theta is 135 degrees, 225 degrees. And finally, the last thing we do is to look up at our given interval, make sure that our answers fall within that interval. If they do, they work. If they do not, they're extraneous. So don't worry, I know it hasn't happened yet, but it will happen. Last one on this page that we're going to look at is number 6. We'll look at a tangent example. So this, again, just think of this as a variable. Maybe we'll call that one z. We're trying to get z by itself by getting them all together on one side. So subtract tangent. This is like 3z minus 1z. So that would be 2z, or 2 times tangent, is equal to the 2, which got left on the right-hand side. And then divide both sides by 2. We're trying to get this tangent by itself. So tangent of theta equals 2 over 2, which is 1. Okay, the tangent ones are always just a little bit trickier. Remind yourself that tangent is the y-coordinate divided by the x-coordinate. So y divided by x. So this one, think of it this way. If the division ends up being 1, that means that the values are the same. Okay, the values are the same, meaning the y-coordinate divided by the x-coordinate, they must match perfectly. Okay, so if we're in the first quadrant, these don't match. These do, okay? Number 6, they asked for our answers in radians. So we would give pi over 4 as our first answer. So we have theta equals pi over 4, comma, and then we're looking for the other one where they are exactly the same. Close, but not good enough because y over x would be a -1. That's not what we're looking for. This one, they would match perfectly. So in radians, that would be 5 pi over 4. These ones are close, but again, don't match perfectly. So 5 pi over 4. Okay, so check for extraneous solutions, which means check our answers against the range. Between pi over 2 and 3 pi over 2, pi over 2 is right here, 3 pi over 2 is right here. So we only want these answers, which actually cuts this one out. So extraneous solutions, you should put an X through it. And then we say that the only solution that actually works is a 5 pi over 4. Okay, so that's how this works. I wanted to make sure you saw an example of sine, cosine, and tangent. On the next page, our work is going to get just a touch more complicated because there's going to be some factoring involved. So on this page, we're going to do the odds. These are examples that involve factoring. So we have some algebra stuff to practice first, and then we are going to solve using the unit circle, just like we did on the front page. So we have some different factoring methods that we're going to practice. Factoring always begins by getting everything on one side of the equation. So a lot of them start with equals 0. It's really just these bottom two that don't. So you want to make sure everything's on one side. Any factoring method applies. That includes GCFs, normal trig or normal trinomial factoring. You might have to do slide divide. You might have difference of squares. We've got a little bit of everything here. So these ones, we look for a GCF and we have a sine theta that we can factor out. So factor out a sine theta, then you put your leftovers in parentheses. So if you divide out a sine, you're still left with a sine. Think of these as like y's. If this is a y squared and you take out a y, you still have a y. Plus, and then you factor a y from a y, and that leaves you with a 1. So those are our factors. We have 2 factors. Just like normal factoring, you take each one of them and set them equal to 0. So set that one equal to 0. Set that equal to 0. All of these solutions are given in degrees, and they're all the answers that are included in one full lap around the unit circle. So basically anything that you see on the unit circle would be fair game. So here we want where sine of theta is equal to 0. Remember, that's the y-coordinate. So let's do a lap around the unit circle. We want a y-coordinate of 0. That's here at 0 and 360. It's also over here at 180. So 0, 360, 180. Okay, and then this, just do a quick subtraction, where sine theta is equal to -1. Okay, so where the y-coordinate is -1, and that would be this bottom point on the unit circle. So that would be 270. So we have 270 degrees here. We're not worried about extraneous solutions because all of them are working off of this interval rather than a reduced interval like we had on the first page. So 4 different answers here that would make that true. So sine squared plus sine is equal to 0. For the most part, it's because they're equal to 0. But like this one, 270, sine squared would be positive 1 plus just sine would be negative 1. All right, let's keep going with these odds. This one, you've got a quadratic, which means everything's on one side. This is kind of a traditional factoring pattern where you have a sine squared. So think of it if like you had a y squared right here. You would have 2 sets of parentheses like this, equals 0. So sine squared is sine times sine, like that. Now we want to multiply to a negative 4 and add to 3. So that would be a plus 4 and a minus 1. So that factors, think of it like y plus 4, y minus 1. Just like number 7, you are going to take each one of these and set them equal to 0. So here, if we isolate the trig expression, we get sine equals negative 4. Here, if we isolate the trig expression, we get sine equals 1. Now, we talked about this in the past. Sine and cosine never go beyond positive 1 to negative 1. It's like sine of negative 1. Negative 4 would be way down here. Like this is 1 unit. Negative 4 is not going to happen. The unit circle does not go that far. So this doesn't give you any solutions. This one does, though, where sine is equal to a positive 1. Only happens once. It's at this value right here, 90 degrees, because we're supposed to give our answer in degrees. So just one possible answer for this one versus the 4 answers that we came up with for number 7. So anything's possible here. Number 11, everything on one side, set it equal to 0. This one I'm hoping you recognize as the difference of squares. We always look for a GCF, especially when there are only 2 terms. That's how we did number 7. But there's no GCF here. This is technically a perfect square because this is 4 and this is squared, and 1 is always a perfect square. So you set up your 2 sets of parentheses. For 4 cosine squared, we do 2 cosine times 2 cosine. And then for the minus 1, we have a plus 1 minus 1. So that is our difference of squares pattern, that a plus b, a minus b. So we can take each one of these factors, set them equal to 0. So hopefully you guys are feeling confident by now in using that unit circle. So this one, if you want to isolate cosine, you do so by subtracting the 1 from both sides and dividing by 2. Okay, so same thing here. You subtract this time you add the 1 to both sides and you divide by 2. Another way that you could solve for this, if you're looking at number 11 from the beginning, you could have added 1 and divided by 4. So you'd have cosine squared equals 1/4, and then you could have solved it by taking a square root. If you take a square root, you get plus or minus 1/2. Here's the plus, here's the minus, 1/2. So we're looking for all the angles all around the unit circle that have either a positive 1/2 or a negative 1/2 as their x coordinate. Okay, so that is this one right here. So that's 60 degrees. And then you have a negative 1/2 here, a negative 1/2 here, a positive 1/2 here. So all of those that have 60 as their reference angle. So 60, 120, 240, 300. Okay, so 4 different possibilities for that one as well. And again, we're not worried about anything extraneous because they use the whole unit circle as our domain. Last one, number 13. This one, we need to start by subtracting the 3. Because it is a quadratic, you want to make sure that everything is on one side. And then for this one, you see there's something in front of the cosine squared, which would be like having something in front of the x squared. If that doesn't divide out, which it does not, that is when we do the slide and divide method, okay? If it can divide out, you have to, because if it can divide out, slide and divide won't work. But if it can't, then you do slide divide. So the 2 slides over here and makes this a 6, and then I factor this down. So my cosine squared means I start with cosine times cosine. I am multiplying to a negative 6 and adding to a negative 5. So multiplying to a negative means 1 minus 1 plus. And then the negative 5 means I have minus 6 plus 1. Okay, so to finish this off, remember you have to redivide by that 2 that we started with here. All right, so like that. So this reduces down to 3. This does not reduce at all, so that means the 2 comes back to the fronts, and this is my second factor. Okay, so finally, set each of those equal to 0, just like I did with the others. When I set this equal to 0, I get cosine equals 3. 3 is too big. That is not going to give me any answers, just like this one. I only have values between 1 and negative 1. This one, when I set it equal to 0, I subtract 1, divide by 2. So these are just the negative values. So same solution here, except I only want the negative ones. That would be only the ones in the second and the third quadrant. This is the second, this is the third quadrant. And so I have theta equals 120 and 240.